Hi students, this is Mr. Yao. Today we're going to talk about 5.7, where we'll learn about features of quadrilaterals and parallelograms. First, let's look at the definition of quadrilateral and parallelogram. A quadrilateral is a shape with four sides. Any kind of shape with four sides is a quadrilateral. Parallelogram is a special kind of quadrilateral. It is one with both pairs of opposite sides parallel. We use this symbol. We actually draw a little parallelogram to actually indicate a parallelogram. And the key is, this is the definition. So if we actually don't learn any theorems, or if we're trying to prove theorems, we can't use any other things. So the only thing we can use is this definition, that both pairs of sides, opposite sides, are actually parallel. So this is actually very important. Next, let's have a look at some theorems and properties we can use when we're proving, or some features of just parallelograms. So first, if a quadrilateral is a parallelogram, opposite sides are parallel, that is a feature, which is also the definition of parallelogram. Also, the opposite sides are congruent, and we're talking about both pairs of opposite sides. Next, opposite angles are congruent, both pairs of opposite angles. Next, diagonal bisect each other. Last one, same side interior angles of quadrilateral of parallelogram are supplementary. And I'm just listing two pairs. There are also the other two pairs, just because they're all parallel lines. So we basically have two transversals. So we end up with four pairs of same side interior angles. So these are the features if we already know it's a parallelogram. The right side is actually more important because this is what we're going to use to prove. To prove the quadrilateral is a parallelogram, we have to show, we can use a theorem called converse of opposite sides are parallel. If we actually show both opposite sides are parallel, then we can just say the reason is converse of opposite sides are parallel. Then we can say the quadrilateral is a parallelogram. Next, same idea, converse of opposite sides are congruent, converse of opposite angles are congruent, converse of diagonals bisect each other. The last one is actually the most important one because it's slightly different. The other ones you can kind of find, you can kind of see it's corresponding first one, second one, that is with like third one, and that is the fourth one. The last one is the only one that's different. One pair of opposite sides are congruent and parallel. So we can just use one pair of lines. So for example, the CD and let's say DC is parallel with AB, and we can also say DC is congruent with AB. That is how we can actually prove it's a parallelogram. We just use the one pair of lines. Next, let's have a look at some solving questions. Example 1, 2, 3, and 4. Number 1, these are opposite angles. So question mark is 64 degrees. And number 2, these are opposite angles. So 11x equals 55, which gives us x equals 5. And these are parallel opposite angles, but these two, they are same side interior angles. So 11x plus 5y equals 180. We already know 11x is actually 55. 55 plus 5y equals 180. After solving, 5y equals 125, so y equals 25. So we have the answer, x equals 5 and y equals 25. Next, number 3. These are opposite sides, so 2x minus 6 equals 16, x equals 11. Here's opposite sides, so y plus 3 equals 12, y equals 9. And then we also have the other pair of opposite sides. So we have 6x minus 7 equals 2x plus 9. That gives us 4x equals 16, x equals 4. That's the first 4 examples. Next, example 5. NG, this part is 23. EG, this whole thing is 14x plus 4. If you remember, the diagonals are being bisected. So we basically know this part is 23, but that part would also be 23 because they are the same. So that's also 23. 14x plus 4 is actually equal to 23 plus 23, which is 46. So 14x equals 42, x equals 3. That's example 5. Next, example 6. Bisect, so that means 3x equals 12, x equals 4. And then we have the other diagonal that's also being bisected. 4y plus 4 equals 5y, and that is going to give us y equals, that's example 6. Next, example 7. So this question actually made a mistake, and your job is to find out what that mistake is. So you might want to pause it here and actually think by yourself. Hopefully you have thought for a second. The mistake I made is, yes, the diagonals bisect each other, so these two actually are going to be the same. But if we actually want these to be the same, then parallelogram is not the one that actually can make that work. If you actually draw a more special one, like there's no way these two parts are actually the same. I'm going to draw even more dramatic. Like there's just no way these two parts are the same. And if they are actually the same, it's going to be a very special case. It's when we actually have a rectangle. That is the time it can actually make it work. But then this would actually be a 90 degree because that is going to be less than 90 degrees. So this problem actually does not work. It does not work. Number 8, opposite angle and opposite side. So we got 2x plus 40 equals 70, x equals 15. And then we also have these two being opposite. So 5y plus 15 equals 110. So 5y equals 95, y equals 19. And lastly, we have these two being opposite. So 4z plus 20 equals 2z plus 30. So 2z 10, z equals 5. That is example 8. Now let's have a look at some special types of parallelograms. We're going to look at 3 of them. The first one is a rhombus. A rhombus is a parallelogram with 4 congruent sides. So these definitions are actually more important than proofs because we actually sometimes may prove the theorems. So 4 congruent sides. And all sides are congruent, diagonals are perpendicular, diagonals bisect each other, and opposite angles. So that means bisector are actually meeting at a midpoint, and also this opposite side is basically saying that the bisectors are angle bisectors. And here are ways to prove them. We actually always can use the definition. The diagonals are actually perpendicular, then it's actually a rhombus. Each diagonal bisects a pair of opposite angles, so that's saying angle bisectors. So that's the 3 ways to prove it's a rhombus. Next, rectangle. This time it's a parallelogram with 4 right angles. So you see the first one, rhombus, is 4 congruent sides. Rectangle is 4 right angles. So of course all the angles are 90 degrees. Diagonals are congruent. And now you can kind of see what we did with example 7. So it has to at least be a rectangle for it to work. Next, diagonals bisect each other. So that's kind of something slightly different. This time it's just they're bisecting each other and nothing to do with the angles. 2 ways to prove. One, we can use the definition. All angles are right angles. And the second way is diagonal are congruent. This is the only time a parallelogram can actually work. Next, square. Square is actually a combination of rhombus and rectangle. So you see 4 congruent sides and 4 right angles. So that's why we're just combining the features of a rhombus and a rectangle, and ways to prove it just has a bit more. All sides are congruent and all angles are right angles. Or we can say it is a rhombus, prove that first, then also prove it's a rectangle, and say exactly both. That could also work. Now let's have a look at some practice questions. Number 1, decide if each shape is a rhombus, a rectangle, or a square. Number 1, there's no angle indicated even though they look like 90 degrees. We only know the 4 sides are the same, so that is going to be a rhombus. And number 2, same thing, only indicating the 4 sides are the same, so it's a rhombus. And C, opposite sides are congruent, and also a bunch of right angles, so that is going to be a rectangle. The last one, sides are all the same, so that is a square. Example 2, draw a rhombus JKLM. Decide whether each one is always or sometimes true. So this time you're trying to actually find counterexamples to decide if it's always going to be true. Draw a rhombus. I'm just going to draw a random rhombus. As long as all the four sides are the same, I can say J, K, L, M. You can see L and M are right here. Clearly, that is not always the congruent, so sometimes. I'm just going to write S. Sometimes. And next, K and M. These are opposite angles. One definition about rhombus is the opposite angle. Well, actually, one definition for parallelogram is how it's going to be. And rhombus is also going to follow that. So in this case, a rhombus is always going to make sure the opposite angles are congruent. J, M, and KL. These are opposite sides. Of course, they are congruent. Actually, all four sides are congruent. Indicate that. And then J, M, and KL. Well, that's actually the same. Still, J, L, and KM. Even in the ones we just draw, these two lines are clearly not congruent, so it's sometimes. J, K, M, which is this angle, and L, K, M, which is this angle. And we know the rhombus, the diagonal is actually going to be angle bisectors, so that is always going to be true. Next, example 3. Draw a rectangle. So this time a rectangle. Remember, a square is just a special rectangle. There's that. These, and it's W, X, Y. You might be wondering, wait, do I have to write them in this order? Yeah, well, it doesn't matter. I can also write my W here and then X, Y, Z. As long as if they are in order, then that is fine. Okay, so let's have a look. W and X are always the same. Well, they're always 90 degrees. So, of course, they are going to be the same, always. Next, WX and YZ, they are congruent. Well, they're opposite sides of each other, so of course, they're always going to be true. WX and XY, well, these two, we don't know. These two are next to each other. If we want them to be true, that has to be a square, so it's only sometimes. Next, WY and XZ. Now that's the diagonal, and rectangle is the one that actually have congruent diagonals, so that's always true. Next, WY is perpendicular to XZ. That is not guaranteed. In the graph I just draw, that is not the case, and only a square can actually make them perpendicular to each other. Next, WXZ, which is this angle right here, WXZ, and YXZ, and that angle. So of course, they are not the same, just as the one we can see. Because a rectangle is not a rhombus, it's not guaranteeing they are angle bisectors. That is example 3. Example 4. AC is 2x plus 13, and BD is 4x plus 25. So of course we can see they are the same, but because they're both diagonals of a rectangle, 4x plus 25 equals 2x plus 13. 2x equals 12, x equals 6. Next is also asking to solve for AC and BD. So AC is actually the same as BD, which means we just plug them in. 4 times 6 plus 25, which is 49. Did I solve that right? Oh, actually, it's going to be a negative 6. Negative 6. That actually is going to be a 1. Because 13 minus 25 is negative 6. Okay, that's example 4. Example 5. Find x and find y. We see that is midpoint right there in the middle. So 2y equals 10, y equals 5. Next, 5x is right there. And 3x plus 18, that's a rectangle. So basically that means these two opposite sides are parallel. So they are alternate interior angles. 3x plus 18 equals 5x. And x equals 9. That is example 5. Next, example 6. The diagonals of a quadrilateral LM and P intersect at K. And LN is perpendicular to MP. This doesn't happen a lot. So a rhombus can work, a square can work, but not a rectangle. LK is 1, which you can start labeling. That's a 1. well, MKN, that angle for sure is also going to be 90 degrees. So after knowing these facts, we can narrow it down to being either a rhombus or a square. There's nothing else that we actually we know. So our Kn, at least we know that is a 1. And as for MP or LP, we, as of right now, we actually don't know because we don't have enough information. So this question itself, again, is unsolvable unless we have decided, oh, you know what, it's actually going to be a square. So I'm going to change the question a little bit to make it work. So LK equals 1, which also equals MK. Let's say that's the case. In that case, if this is also 1, that's also a 1. Then all these are the same. This is guaranteed to actually be a square. It has to be. And in that case, these are all 45-degree angles. 45. And MP is 2. LP, if you actually look at this right triangle right there, you can use Pythagorean to solve it. LP is square root of 2. That's example 6. Next, example 7. BF is right here, 12. And DE is also 12. CF is 8, is asking for AE. Just by looking at it, you kind of know what AE is. But it also said, explain your reasoning. So let's start labeling things. We know these two sides are the same. And if you have a look, that is a parallelogram, which means we have more than that. We actually have pairs of angles. They are interior, alternate interior angles. That is one pair of angles. And also because of the parallelogram, so these two sides, the opposite sides, have to be the same. So by SAS, we know triangle ADE is congruent with triangle CBF. In this case, we can actually prove AE is congruent with CF. That is why AE is actually going to be 8 as well. But the reasoning is actually important as well. That is example 7. Now that's everything for 5.7a. Thank you.